Is there a protocol regarding the method of installation of the light sensors? Well, I think it depends on whether you have like a metal clad switchgear and what points where we would have blind spots in the actual arrangement within the switchgear cabinet. Sometimes we have utilized probably 3 sensors per section, so that might be an initial starting point for this design. Are there light and pressure sensors adjustable? They are not adjustable. So for the pressure sensor, because it's mechanical, it's going to act a little bit slower at around 10 milliseconds versus the light sensor, which is strictly electrical and light based with fiber optics, which is our fastest solution. Now, the pressure sensor's sensitivity is between 0.2 to 0.5 BAR. And with respect to the next question in terms of custom procedure based upon the application, you're correct. It will have to be sensitive to the application, and we would probably need to interface with the switchgear manufacturer and give them advice on where to place these sensors. Will the system have nuisance tripping if external light shines on the sensor? The answer is no, because we're looking for a particular spectrum of light emitted by the arc flash condition, and that is a very particular spectrum such that we avoid nuisance tripping. Can you discuss the DSP's ability to monitor each feeder and trip the lowest priority feeder upon second phase to ground fault? We can, for sure. So the DSP system, upon first fault, you don't have to trip because the fault is being limited to 5 or 10 amps on as a standard. But if there's another fault on another feeder on another phase, we have a phase to ground to phase failure where the current circulating between these 2 points is going to get extremely high. In this case, if you didn't have the DSP system, your instantaneous function of your breaker would trip out both of the faulted feeders due to the high level of current detected by the instantaneous function. What our DSP system is designed to do, though, is to have a lower pickup of 100 amps such that before the instantaneous can even react, we selectively trip the lower priority of the 2 feeders that are faulted so that we can revert back to our first fault condition. Will flash from a camera trigger the arc flash module to trip a breaker? No, it will not, because we're looking for a particular spectrum of light. Does the unit have self-diagnostics provisions? Usually when we have this unit set up and commissioned properly, we don't need to do much self-diagnostics, but I will have to check and see if we also do a test feature for these arc flash module to confirm that for you, Manuel. Are false trips a problem? No, they are not, because we're avoiding nuisance tripping when it comes to detecting the particular spectrum of light and not just any light going to these fiber optic sensors. Are there light only or light and current sensing? We do have an option for light and current sensing, and that is our ARC-i-TEC relay. At the moment, this module is only focusing on light and pressure at the moment. What about medium voltage systems without CTs? For example, fuse load break switches. For medium voltage systems, we would recommend using the ARC-i-TEC relay so that you can have CTs and light detection. Typically, the DSP system is reserved for systems that are strictly 5 kV or below. What kind of external power is needed to be able to maintain functionality during a fault? Well, we have power to the relay, and when the fault occurs, we will be tripping the upstream breaker. Depending on how the relay is powered, breaking open of that main breaker may cause the relay to shut down if you have CPTs connected on the load side of the main breaker. But if the CPT is connected on the line side of the breaker, we should be able to still be able to pick up the fault scenario. Is there a chance of conflict with PNC systems? It's possible, but I think you would have to work on the coordination of the settings for your protection and control system with respect to the other relays that are also offering protection and control, so that we have a method of organizing and coordinating those protection and controls. Are these point sensors only, or can you also connect fiber loop sensors? I believe that these are point sensors only, but we may also be able to do fiber loop sensors. I I think I'll have to seek clarification on that. In most of the cases that I've been involved in, we've only used point sensors, but I can ask about the fiber loop sensors and get back to you. Are special high-speed breakers required with the ARC flash system and cannot just be retrofitted to an existing system? What is the typical time a breaker takes to clear the fault from receiving the trigger? So typically breakers use 5 cycles before they can trip, but our command from our relay sends it within 10 milliseconds. So 5 cycles equates to about 0.1 milliseconds or 100 milliseconds. I've seen that in some cases there are 3 cycle breakers, which may be utilized to trip even faster. So I guess it's up to the design stage. What diagnostics are available? For the diagnostic aspects, it's probably mostly with respect to visual. So I think that when the arc does occur and you see that the tripping is coming from the DSP ADM module, you know that there was an arc previously in the system. So you would need to do visual investigation to see, while the system is de-energized, what would be the cause of this failure that has occurred and how the relay has suddenly tripped. How effective is the pressure sensor? The pressure sensor is pretty effective in terms of being able to mitigate the arc flash energy and being able to detect it. We've done a few internal tests where it's been quite as effective as the arc flash sensors, like the fiber optic ones. So it's been a valid way to mitigate arc flash energy. Does the relay indicate fiber health? I don't believe it does, but these fibers are quite stationary internal to the switchgear. So I'd imagine that if the unit is properly commissioned, then we shouldn't see any impact on those fiber optic cables that have been set up. Is there a limitation of application in terms of the bus current and voltage too high? We use the DSP system usually for systems that are 5 kV or less and utilizing high resistance grounding. We do have another product called the ARC-i-TEC, which uses both current and light sensors and pressure sensors to pick up arc flash incidents. So the ADM module was actually manufactured based on the ARC-i-TEC, except we decided to only use light sensors. Can this be used in low resistance grounding? I suggest that for the low resistance grounding aspect, you would go with the ARC-i-TEC instead, which can do both current and light. This additional module is only in relation to when we have high resistance grounding. Do you use pressure sensors as a double check, or do you use a current sensor to double check of the light trigger? So at the moment, this optional module for the DSP system doesn't use a current aspect. It only uses light or pressure. And the reason being is because we already have high resistance grounding handling majority of the cases for the phase to ground failure. We just wanted a little bit extra protection in terms of using light and pressure sensors to establish whether there's an arc coming from a phase to phase or a phase to phase to phase failure. Would arc resistance gear be necessary if using smart? I would say it doesn't hurt to have multiple levels of protection. So arc resistant gear, it could be utilized, but I'm not sure if it's a necessity if using smart HRG or not. What about cost point of pressure sensors? Which method is the most cost effective? So as far as I know, the pressure sensors and the light sensors are about the same price, plus or minus maybe a few $100. So either one can be used, but we typically use like a combination of pressure and light. So maybe some of the sensors will be pressure based and some of them will be light based. What is the reaction time for the pressure and light sensors compared to that of a ground fault? When there's like a standard phase to ground fault, we are usually picking up neutral voltage and neutral current on the high resistance grounding system, and that's usually picked up by a CT fairly quickly. Pressure and light sensors are very fast as well. I think our clearing time is about 10 milliseconds as we send the signal to the breaker, and the breaker would typically be 5 cycles. So we're looking at roughly around maybe just slightly above 100 milliseconds here. Do some of the fiber sensors have UV coating to prevent false triggering due to sunlight? Our fiber sensors, I don't think that they have a UV coating. I'm not 100% sure, but I know that we are trying to mitigate nuisance tripping in relation to lights and cameras flashing and that sort of thing by trying to detect the particular spectrum of light emitted by an arc flash incident. So we shouldn't have an issue with sunlight triggering the arc flash on these sensors. sensors. Do you have to reset the ADM after an event, or is it a one-time and done? You would have to go and reset the module on the DSP system overall because there is a tripping event. So we need to indicate to the customer that the ADM has picked up this, so it remains in a state of being active and indicating that a fault has occurred. Your system at this point should be completely offline because usually the ADM is wired to the main breaker to shut the entire system off before severe damage is occurring, since usually we only have like one dry contact on these to go to the main breaker or the upstream breaker. Can it be used for high current 4000 amp DC and high voltage 450 DC on DC circuits like the excitation system output circuit? We can probably do the DC based variants with the ARC-i-TEC unit, which is the combination of using an ARC relay that has both current and light and pressure sensors. For 4000 amps DC, yeah, I think that the ARC-i-TEC would be a better solution since typically DC doesn't use high resistance grounding often. Would the trip lock out the breaker? The trip is supposed to open the breaker, but you would have to further verify with lockout tagout methods to confirm that the system is completely de-energized. Ideally, we should be tripping that breaker, so it should be in the open state. What is the approximate time of an arc occurrence? Well, I think that depends on where the arc is coming from, how much current there is, and how much time has elapsed. Usually, if we're trying to pick this up as fast as possible, you saw that on the pressure waves and the light emission waves in the previous slides, we see that it's happening in just a few milliseconds. So the faster that we can reduce that exponential rise, then we have, a better chance at reducing the magnitude. How does the DSP unit indicate that a phase-to-phase or phase-to-phase-to-phase arc flash has occurred? That's the main point for this ADM module, since the high resistance grounding cannot pick up the phase-to-phase and phase-to-phase-to-phase failures. Usually your instantaneous function of your breaker should be sending a trip command when it sees high levels of current, but that's why the ADM module is there to kind of catch it in advance before your instantaneous picks up on the fact that there's high levels of current so that we can just trip faster. Is there a threshold of service size where ground fault detection is recommended? I think we have service entrance relaying requirements in section 14, like if you have solidly grounded systems. Aside from that, high resistance grounding we've seen it being used at 500 kVA, 1000 kVA, and even higher. And depending on whether the customer wants additional level of detection on the feeders, we can offer the DSP system. If they just want to be able to detect a ground fault, then we can offer our Sigma 3C relay, which monitors the resistor and monitors for ground faults in the system. How did you go about calculating or determining arc flash pressure? You can look at IEEE 1584 for the calculations on incident energy based on the voltage that you have, and from there you can see how much cals you would have when an arc flash would occur. In the graph that we showed, that was taken from another source, and we can provide that information to you